Think about the early universe. Okay, in the early universe, shortly after the Big Bang, matter and antimatter were created in equal amounts. However, a slight asymmetry between the two led to a dominance of matter. That means this universe is full of matter. That means matter dominates in this universe, that means in our universe, which is why we exist today. This asymmetry is one of the biggest unsolved mysteries in physics. And that leads to a very fascinating question, whether is that possible that after the Big Bang, another universe made of antimatter is there somewhere? Hello and welcome to Students, a channel for intelligent and curious people like you. Before we proceed, let me tell you one thing. If you have not subscribed yet, please subscribe. It means a lot to me. And if you have already subscribed, tons of thanks for your support. Look, the possibility of another universe made entirely of antimatter after the Big Bang is an intriguing idea, fascinating idea. But it's important to consider the evidence and theories we have that suggests that, first of all, matter-antimatter asymmetry. Let us try to understand that. It is one of the biggest mysteries in physics, right? In cosmology. Because why there is an imbalance between matter and antimatter in our universe? Shortly after the Big Bang, equal amounts of matter and antimatter were created. What those antimatters done? Somehow matter became dominant here. And understanding this asymmetry is crucial to understanding the nature of our universe. Now look, there is no direct evidence, isn't it? Because while there is no direct evidence of an antimatter universe, is there some theories are already there that suggest that such a universe could exist. For example, some cosmological models propose that our universe could be a bubble within a larger multiverse, and other bubbles could have formed with different initial conditions, potentially leading to antimatter-dominated universe. Now, what are the challenges and considerations? Let us consider those factors also. Number one is observational limitations. Detecting an antimatter universe would be extremely challenging, as it would likely be separated from our own by vast distances. Current telescopes that we have and detectors are not capable of directly observing such a distant universe. And what are the theoretical challenges? While some theories allow for the possibility of an antimatter universe, they often involve complex and speculative ideas about the early universe and the nature of space-time. Now, the concept of an antimatter universe raises questions about the causes and the arrow of time. That means, if such a universe exists, would it experience time in the opposite direction? Think about it. These are complex questions that physicists are still grappling with. And finally, for laymen like us, I would like to give you an introduction of some matter and antimatter kind of things. That means what is matter and what is antimatter. What are the key characteristics of antimatter? Number one is opposite charge. That means antiparticles have the opposite electric charge of their corresponding particles. For example, the antiparticle of an electron, called a positron, has a positive charge. Same mass. That means antiparticles have the same mass as their corresponding particles. Electron and positron will have the same mass. Annihilation, which is a very interesting topic, and in our future video we'll talk about it in addition. When matter and antimatter meet, they annihilate each other in a burst of energy, huge energy. It generates huge energy, and it releases photons. I talked about photons in my early videos, which we call light particles. And examples of antiparticles, positron is the opposite of electron, antiproton is the opposite of proton, and antineutron is the antiparticle of a neutron. Antineutron, antiparticle of a neutron. And where does antimatter come from? We can create it by particle accelerators. Scientists can create antimatter in high energy particle accelerators by colliding particles together at incredibly high speeds. A natural process, if you think about the natural process, some antiparticles like positrons are produced naturally in processes like radioactive decay and cosmic ray interactions. And you can ask why antimatter is important. It is important because to understand the universe, antimatter plays a very crucial role, because it is one of the fundamental forces of nature and the origins of the universe. The fact that our universe is primarily made of matter, not antimatter, is also a major unsolved mystery in physics and cosmology. Antimatter has potential applications in medicine. So in medical applications we see, such as positron emission tomography, which is we also call PET scans, PET scans, which is used using positrons to create images of the human body. And finally, the energy source. The immense energy released during matter-antimatter annihilation could potentially be harnessed as an energy source, and it will solve our energy source forever in our world. Though this is currently highly theoretical and technologically very, very challenging factor. So that is it. And let us think about the current universe, because in the present universe, matter and antimatter are relatively rare. They are primarily produced in high energy environments like particle accelerators or cosmic ray collisions. When they do meet, they annihilate each other, releasing energy in the form of photons. And small scale annihilation is possible because while large scale annihilation events are very, very rare, small scale annihilations occur constantly in various cosmic phenomena. We see, for example, positrons, that means antimatter counterparts of electrons, produced in radioactive decay or cosmic ray interactions can annihilate with electrons. But that is a very small scale annihilation, and that may occur in our universe in a distant galaxy. We don't know. Still we don't know. So that is it today from me. The next video will come up with a new video, of course, on physics and science, on cosmology. So see you in the next video. Till then, goodbye. Thanks for watching. Take care. Stay safe.